So the second part of our law of sines and cosines exploration is talking about the ambiguous case, and we referenced it a little bit yesterday. The ambiguous case occurs when you have two sides and a non-included angle. So that means that the angle is only touching one of the sides that you are given. And it's called the ambiguous case because we could have um, 0, 1, or 2 triangles with that information. And you may say, well, how is that so? Well, if we take the inverse sine of a number less than 1, so like the inverse sine of 0.2, let's use a unit circle one. Okay, so the inverse sine of 0.5 is 30 degrees. Well, we also know on the unit circle that 150 degrees also has a sine value of 1/2 or 0.5. So what that tells us is that if we get to a situation with the law of sines where we have to take the inverse sine of 0.5 or inverse sine of 1/2, well, that angle could be 30 degrees or it could be 150 degrees. So we have to use both situations. So when we take the inverse sine, we're going to have to do 180 minus that angle. You may say, well, why didn't we have to do that yesterday up here when we had to find, we had to find the inverse sine right here and get 34.42 degrees. Well, again, the reason why it worked yesterday is we were finding the smallest angle. And we knew it was the smallest angle because it was across from the smallest side. Our first step yesterday was to find our missing side, A, and then since we knew what all three sides were, we could find the smallest angle from that and use the inverse sine. So because we approached the problem that way, we didn't have to worry about the other angle when we do the inverse sine. In today's stuff, because we have two sides and a not included angle, we don't know if that third side is the longest side or the shortest side or in the middle, so we have to account for both situations. So we're going to do a little bit the same thing we did yesterday. Draw a triangle and label the given information, but then we're going to create a table with two possible triangles, and we're going to find all of the parts. And again, when you're doing the inverse sine, you have two possible angles. And what we need to make sure is, as we're doing these problems, check to see if your values make sense. For example, if we get a situation where the angles add to more than 180, well, we know that triangle doesn't exist. And there are ways to figure this out if there are 1, 2, or no triangles, but it's another formula to remember. I just think it's easier to assume that there's going to be 2, but then think as you're doing the problem if it makes sense. Again, things to watch out for: all angles add up to more than 180 degrees. And if the angle given to you is bigger than 90, then two triangles can't exist because we already have one angle bigger than 90. The other one can't be bigger than 90. Again, can't do the inverse sine of a number bigger than 1. And the largest side should be opposite the largest angle, and smallest side should be opposite the smallest angle. So when we solve these problems, we're going to be looking at that as well. So let's look at our examples here. So first step again is always going to be to draw a triangle, A, B, C, and we label angle A 62 degrees, side A 10, and B is 12. Okay. So this is an SSA situation because we have two sides given and the angle we are given only touches one of the sides. So this is SSA, which means we have to account for the ambiguous case. All right, so now we have to find angle C next. So we have two possible triangles. We have triangle 1, triangle 2, and we need to figure out angle C. We need to figure out angle B and side B for both triangles. Now, if we get a situation where it doesn't make sense and we only, let's say we find angle C and it doesn't make sense, we don't have to keep going. We can just say, all right, we're done. So let's set up the law of sines. Sine of 62 degrees over 10 is equal to the sine of C over 12. All right, so then we'll cross multiply and divide. So we have 12 times the sine of 62 degrees over 10 equals the sine of C. So we type that into our calculator, and for the first few I'll do it on screen, and then I'm going to do them off screen because it's a little bit quicker. 12 times the sine of 62 degrees divided by 10. I'm going to make sure I'm in degree mode. Good. So we could enter, and we get 1.059. 1.059 equals sine of C. Now, if you can see at this point that there's no triangle, you can say that, but if you need to do this step right here, if I try to take the inverse sine of that, it's a number bigger than 1, so I'm going to get an error. See, when I hit that, I get error domain. So that means there are no triangles at all. So gives an error, no triangles. So we don't even have to worry about the possibility of a second one because the first one doesn't even exist. All right, so now example B, let's draw a triangle, A, B, C. Angle B is 98 degrees, side B is 10, and side C is 3. And we have side A. Now, we look at this and we have, again, two sides and an angle, and our angle only touches one of the sides. So this is SSA. Now, you might be saying, well, all of them, since we're doing the ambiguous case today, all of them are going to be SSA. And yes, that is going to be the case, but when we start mixing all of these together, I want you to see the process of, okay, how do I know that this could be a possible ambiguous case? Right, so we have two sides and the angle only touches one of the sides. Now, I also notice that 98 degrees is bigger than 90, so we can't have a second triangle. Because when we do the inverse sine, and let's do this problem and I'll explain better when you can see it. So we have triangle 1 and triangle 2. In the future, though, you could just say that there's only one triangle, but I'm going to show you why that is the case. So we have angle C that we have to find, angle A, and we have side A. So we're going to do sine of 98 degrees over 10 equals the sine of C over 3. So then we cross multiply and divide. So 3 times the sine of 98 over 10 equals sine of C. So I type that into my calculator, and I get 0.2971. 0.2971 equals sine of C. So then the inverse sine of 0.2971 is 17.28 degrees. So 17.28 degrees. Now, if there was a second triangle, then angle C in the other triangle would be 180 minus 17.28. 728. So that would be 162.72 degrees. Well, if we add that to 98, we're already over 180 degrees. So that means the second triangle can't exist. So I want to show you. So if I do the sine of 17.28, okay, I get 0.2971. If I do the sine of 162.72, I get the same thing. That's why the ambiguous case exists, because when we do that inverse sine, remember, when we do the inverse, it's asking ourselves what angle has a sine value of 0.271. And two angles that are less than 180 have that sine value, so we have to account for both of them. These two angles, when we're testing for the two triangles, these two should always add to 180. Right, so now we can find what angle A is. Because angle A is going to be 180 minus 17.28 minus 98, which is 64.72. So 64.72. Now again, we don't need to worry about the second triangle because it already doesn't exist. Right, now we're going to do the law of sines. The sine of 64.72 over A, we don't know what A is, equals sine of 98 degrees over 10. So again, we'll cross multiply and divide it in our head. So that's going to be 10 times the sine of 64.72 divided by the sine of 98. And when I type that in my calculator off screen, that gives me 9.13. So I want to go back and verify that the triangle makes sense, that the first one makes sense. The largest side is 10, and the largest angle is 98 degrees. Those are across from each other, here and here. The side C is the smallest, which means angle C needs to be the smallest, and it is. So this triangle is abiding by the rules of our triangles. All right, let's look at this last two on the next page. We have side C is 29. So A, B, C. Side C is 29. Side B is 46. And this is 31 degrees. So this is SSA because we have two sides and the angle that doesn't touch both sides. It just touched one of them. So we could have two triangles. So triangle 1, triangle 2. We have to figure out angle B, angle A, and side A. So we have to find angle B first because we have side B. So we're going to do sine of 31 over 29 equals the sine of B over 46. So we'll cross multiply again and divide. So 46 times the sine of 31 over 29 equals sine of B. So when I type that into my calculator, 46 sine 31, and remember, make sure to close parentheses. I get 0.81695. So we're going to round that up to actually 0.817. So then the inverse sine of 0.817 is 54.78 degrees. 54.78 degrees. So now for triangle 2, I'm going to do 180 minus 54.78 degrees. That's 125.22. So I'm going to check real quick. Can I figure out angle A in both triangles? Yes, I can. So if I do 180, so 180 minus 31 minus 54.78, 180 minus 31 minus 54.78, we get 94.22. And I'm going to stick with triangle 1 for now and then go back to triangle 2 just so that all my information for triangle 1 is in the same spot. So now we can figure out what side A is. So we have the sine of 94.22 over A equals the sine of 31 degrees over 29. So then we're going to cross multiply and divide that out. So we have 29 times the sine of 94.22 divided by the sine of 31 degrees, and that's going to give us side A. So I'm going to do that off screen. 29 times sine of 94.22, close parentheses, divided by sine of 31. And that gives us 56.15. So 56.15. Okay, so now we have to work on triangle 2. And that's why I gave us a lot of space here, so that way we're not having to write really small. So now with triangle 2, right here, this was triangle 1. Now triangle 2, we have to start where we left off. We found that angle B was 125.22. So we're going to do 180 minus 125.22 minus what we were already given of 31 degrees, because in both triangles, the information that we are given up here is still true. So angle C is 31 degrees in both triangles. All right, so we type that into our calculator and we get 23.78 degrees. So 23.78 degrees. Now we can do law of sines. So the sine of 23.78 over A is equal to the sine of 31 degrees over 29. So same idea, we're going to cross multiply and divide. So 29 times the sine of 23.78 divided by the sine of 31 equals our A value. A is equal to, and we're just going to type that in real quick. A is equal to 22.7. So we go up here, 22.7, and then we're going to go and make sure that these triangles make sense. The largest side is in triangle 1, the largest side here is side A at 56.15. So the largest angle should be angle A at 94.22 degrees. That's true. In triangle 1, the smallest side is side C at 29. So that means 31 degrees should be the smallest angle. It is. And then in triangle number 2, the largest side is side B at 46, which means angle B needs to be the largest, and it is. The smallest side is side A right here, 22.7, and the smallest angle is angle A at 23.78. So one of the things that historically students have struggled with is the difference between side A and angle A. They go together. You look at those two. Are they both the smallest? Is angle A and side A the smallest in triangle number 2? They are. Um, you compare angle A with all the other angles and side A with all the other sides. All right, number 4. Okay, triangle A, B, C. Side B is 15. Side A is 12. 42 degrees. And we don't know what side C is. This is SSA because we have two sides and the non-included angle. So this is an ambiguous case situation. So triangle 1, triangle 2, and then we need to find out angle B. That's going to be the first one we find out because we know side B, angle C, and then side C. So let's start off with our law of sines. We have sine of 42 degrees over 12 equals the sine of B over 15. Cross multiply. We're doing the law of sines so much that we're going to be masters at it very soon. So if we type this into our calculator, 15 times the sine of 42 divided by 12, we get 0.8364. So then the inverse sine of B is equal to, inverse sine of 0.8364. Inverse sine of 0.8364. We get 56.76 degrees. So angle B is 56.76 degrees. So then in the second triangle, we have to do 180 minus 56.76, and we get 123.24. And we were given that angle A is 42 degrees, so we can still have a second triangle. So I'd like to do this first because we saw in that first problem, the second problem, that second triangle couldn't exist almost right away. All right, so now angle C. Well, to get angle C in the first triangle, in triangle 1, okay, so let's work on triangle 1. We do 180 minus 42 minus 56.76. And that will give us, let me just type that in the calculator, 81.24. So 81.24. Let's write that a little bit neater. 81.24. Not much better. All right, so now we can find sine C by doing the sine of 81.24 over C is equal to the sine of 42 degrees over 12. So then we're going to cross multiply and divide. So 12 times the sine of 81.24 divided by the sine of 42 is equal to side C. And if we type that in the calculator, we get C is equal to 17.72. So that was triangle 1. Now triangle 2, okay, we're going to have to go back and do 180 minus 42, because again, 42 was the one that was given to us in the original problem, minus 123.24. Minus 123.24. That's 14.76 degrees. So that second triangle is 14.76 degrees. So we're going to do law of sines again. So the sine of 14.76 over c equals the sine of 42 over 12. Cross multiply and divide, so we have 12 times the sine of 14.76 divided by the sine of 42 equals c. And when we type that into the calculator, we get 4.57 is equal to c. So let's go back up here. 4.57. And again, we'll make sure everything matches up. In triangle 1, the largest side is side C at 17.72, so angle C should be the largest, 81.24. That's the case. The smallest side is side A, which is 12, so angle A should be the smallest it is. It's at 42. And then triangle number 2, the largest angle is angle B at 123.24. So the largest side should be side B. It is at 15. Smallest angle is 14.76. So the smallest side should be the side C, and it is at 4.57. So these two triangles both make sense. So this has two potential triangles. So the process is very mind-boggling, or not mind-numbing, because it's the same thing over and over. But we have to constantly be thinking, does this make sense for this problem? So thanks for watching. Make sure to like and subscribe.